Welcome to another episode of the MRP Easy Manufacturing Podcast. In today's episode, we're talking about capacity utilization. Understanding how much of your production capability you're using is critical. Use too little, and you're wasting resources. Push too close to the limit, and you risk failure and loss. Tracking capacity utilization helps you discover the sweet spot in your operation. So, what is capacity utilization? Capacity utilization in manufacturing is defined as the ratio of actual production output to the maximum potential output. It's expressed as a percentage and is a critical KPI for manufacturing operations. It's different from production efficiency as it provides actionable insights for day-to-day operations. It drives the production planning, resource allocation, and cost management decisions you make every day. Production efficiency measures how well you're handling resource management, labor, materials, equipment. Capacity utilization is the percentage of your potential capacity that is actually being used. Why does capacity utilization matter for manufacturers? Measuring capacity utilization helps SMEs determine why and where production line efficiency may be breaking down or bottlenecking. For example, capacity utilization identifies how effectively production resources are being used, where bottlenecks in equipment stock or supply occur, where expected capacity is either underutilized or overextended, and where gaps in production line staffing exist. As with other manufacturing KPIs, such as raw material costs, warehousing, staff, and labor wages, the capacity utilization metric affects profitability. Utilization metrics drive the cost per unit of the product as well as other factors. A high effectiveness ratio will garner a lower cost per unit. A low ratio will drive a higher cost per unit, lowering your profit margin. It would thus seem a logical conclusion that the closer to 100% utilization, the better. However, that's not necessarily true. In fact, there's a sweet spot that most manufacturers aim for, which not only ensures they're using their manufacturing process effectively, but also allows room for growth. The capacity utilization formula. The concept of capacity utilization is simple. You only need two numbers: actual production output and maximum potential output. The formula takes seconds. Gathering accurate data takes longer, but it's worth it. This single calculation shows exactly how much production capability you're using and how much you're leaving unused. Capacity utilization equals actual output divided by maximum potential output times 100. For example, if you have a hubcap stamping machine that can optimally produce 500 hubcaps during a 40-hour shift, and you actually produce 396 hubcaps in that time frame, the calculation broken down would be 396 divided by 500, which equals 0.792. Then multiply that by 100 and you get 79.2%. Let's take a closer look at both of these numbers, starting with maximum potential output. For our purposes here, we're talking about technical capacity, the theoretical maximum. Maximum potential output. This is the absolute maximum output your operation, machine, or process could produce with the current equipment, unconstrained supply, and a constant workforce. This assumes that everything and everybody is working at 100% capacity 100% of the time. For equipment, many vendors allude to the maximum capacity output in their specifications data and technical literature. Using our hubcap stamping example, the vendor specifies that the maximum potential output of the machine is 500 units per 40 hours of runtime, all other things running at 100%. Of course, that is a theoretical maximum because it assumes there are no glitches in the process, but we'll use it for a maximum potential output. Actual output. This number is also fairly straightforward, but there are some caveats. Actual output is the number of units actually produced during a specific, numerically defined time period. That's where it can get a little tricky. How long a time period should you use to maintain some semblance of accuracy? Some potential time frames include 1 hour, an 8-hour production shift, a 40-hour work week, or a 4-week period measured at 40 hours per week, or 160 hours. This is why choosing the right time period to monitor and record output is so critical. Almost anything, whether machine, production line, or process, can possibly run at 95% or even 100% for 60 minutes. However, in the course of an 8-hour shift, or 480 minutes, flaws in the process begin to show up. Extend that out a week, and you'll begin to see actual numbers that are more accurate. If you want a realistic figure for yearly output, a month-long testing period may be the best approach. The idea is to take a long enough sample to get an accurate average of your actual production output. A longer time period will also account for planned and unplanned downtime. Often machines or even pre-built assembly or processing lines are rated for a maximum output based on an hour of runtime. So you'll need to adjust for that in your calculations. When you plug those two values into the formula, actual output and potential maximum output, you'll arrive at an output percentage that truly is your capacity utilization. How to determine your maximum and actual output? So far, we've discussed what actual output and maximum potential output are and how tracking output over time is important. Next, let's look at ways for actually determining these values to use in our capacity utilization calculations. Calculating actual output. To calculate actual output, you don't need to sit on a stool on the production line with a clipboard and stopwatch. That's not only unnecessary, but unfeasible. You likely already have what you need, particularly if you use an MRP or ERP solution for your manufacturing process. Here are the steps to take. First, review production records and completed units. Then account for quality and defects. Only good units count. Use consistent time periods for accurate measurement. Finally, pull data from your production management system to uncover actual output levels for your workstations, processes, or the whole shop floor. Determining maximum potential output. Determining maximum potential output requires making some choices. Here's what you need to know. What's the difference between technical and economic capacity? Technical capacity is your theoretical maximum with current equipment and workforce, usually related to the number in the vendor specs. Economic capacity is your practical maximum before costs start climbing. It's the point above which the cost per unit rises due to increased labor, additional raw material shipping costs, and similar items. Which one should you use? It depends on your purpose. Want to demonstrate your capacity and bend the truth a little? Technical capacity shows your absolute ceiling. Economic capacity reflects sustainable operations in real-world scenarios. Most manufacturers use economic capacity for planning. What factors determine maximum output? Productive hours per shift, cycle times for your processes, and throughput rates across your production line. These combine to show realistic capacity. Data collection best practices. When you begin to collect the data necessary for calculating your capacity utilization formula, it's good to follow a few best practices. Whether you collect it manually or by using a software solution, follow these important principles. Use longer time periods to avoid temporary fluctuations. The shorter the time period, the less likely the data's validity will be. Account for seasonal variations. Often the data will be skewed and not representative of actual capacity. For example, a toy manufacturer may see a spike around Christmas that temporarily raises the capacity utilization percentage over the 85% sweet spot. Don't panic. Wait for operations to return to normal. Consider related metrics like overall equipment effectiveness. This directly affects capacity by revealing and quantifying product loss. Improving it can increase optimal capacity utilization with a minimum of significant investment. Ensure data accuracy through proper tracking systems. This is one reason spreadsheets and clipboards are often less than reliable sources of accurate data. There's too much room for human error and miscalculation. Additionally, it's often out of date. Real-time software tracking is a more accurate portrayal of relevant data. Finding the optimal capacity utilization rate. While it would seem logical that 100% utilization is the gold standard to strive for, it actually isn't for various reasons. Firstly, a 100% capacity utilization leaves no room or buffer for demand surges or unexpected orders. If you're already running at 100%, you technically can't produce more than you already are. In the same vein, rush orders or sudden customization requests just won't fit into your workflow if you're already going full bore. Secondly, when machines are constantly run at full capacity, you risk catastrophic machine failure. You'll have increased wear and tear on equipment, an increased need for preventive maintenance, and eventually a rise in reactive maintenance when a machine gives up in the middle of a run. Just like machinery, your people can only work at full capacity for a limited amount of time. Eventually, they too may break down, and the fix isn't always as easy as replacing a bearing on a flywheel. Ergonomic issues may also ensue, causing repetitive stress disorders. The physical stress isn't the only thing to watch for. Mental stress can also hurt the smooth operation when running at full capacity. Finally, your product quality may suffer if running under the pressure of constant maximum production capacity. Defects often go undetected, and subpar products are shipped to customers. The 85% sweet spot. For most manufacturers of all types, 85% production capacity seems to be the sweet spot. There are several reasons for this, some of which we've already touched on. 85% balances efficiency with flexibility. You're running effectively, with room to temporarily increase production if needed. It maintains room for growth and unexpected demand. You're able to take on new projects with time to upgrade your operation without straining. Unexpected demand can be easily handled. This target keeps costs optimized while preserving the capacity buffer. Industry-specific targets. Some industries can operate effectively at higher rates, but they follow certain criteria. For example, continuous process industries like chemical plants and paper mills may be able to run effectively at higher production capacity. These are largely highly automated processes with less of a human fatigue factor. Unlike most seasonally driven businesses, they have lower customization requests, meaning less need for flexibility. Most also have a predictable, constant demand for utilities and basic materials. The economics change when your equipment costs millions. Idle equipment is extremely expensive. A steel mill, for example, may accept higher maintenance costs to be able to run at 90% capacity. Spreading costs out matters more in this case. Conversely, custom manufacturers may prefer lower utilization. Think job shops, prototype manufacturers, and engineer-to-order businesses. These businesses, often smaller than most SMEs, need to stay agile. They need the ability to take rush orders, unexpected projects, and maintain a quicker turnaround time. To achieve this, many target a 70 to 75% retention rate to maintain this profile. But the lost efficiency is normally offset by premium pricing for customization and speed. Balancing capacity utilization costs. Here's how the economics work. Your fixed costs, such as rent, equipment payments, and base salaries, will stay the same whether you produce 700 or 850 units. If your monthly fixed costs are $50,000 and you produce 1,000 units, that's $50 per unit. Increase to 1,200 units, and it drops to $41.67 per unit. That's significant savings from the same fixed cost base. But if you push too close to 100% utilization, your variable costs may spike. Over time, pay increases and equipment wears faster, driving up maintenance costs. Defect rates rise. Rush shipping becomes routine, not optional. The takeaway is that the optimal point captures most of the fixed cost benefit before variable costs begin to rise. Examples of capacity utilization. Let's look at some scenarios where capacity utilization can be used. I could go back to our hubcap manufacturer, but the formula can be used for operations other than just manufacturing. In this first example, let's look at a shipping hub, Bob's Box Handlers. We'll call it BBH. Shipping yard example. BBH is a port-side third-party logistics company, 3PL. Their facility is designed to handle 1,000 shipping containers per day, and their operation runs 24/7. So their weekly potential capacity utilization is 7,000 shipping containers per week. Bob tracked his company's actual daily shipping output for 7 days. His numbers look like this. Day 1, 900, Day 2, 850, Day 3, 850, Day 4, 775, Day 5, 825, Day 6, 900, and Day 7, 875. That means BBH's shipping output for the week was 5,975 or 853 per day on average. Plugging his values into the formula, you get 85.3% capacity utilization. Therefore, Bob's company is running very close to the 85% sweet spot. At this time, he may not want to make any changes because he has an extra 14.7% capacity available to meet unexpected increases. It also means Bob could potentially have one or maybe two more shippers and not immediately need to spend money to expand his operation. However, once he does that, he'll need to keep track of his actual output and capacity utilization numbers and determine when it's time to expand his shipping yard. But for now, he has the potential to grow a little without too significant an investment. Seasonal considerations example. Let's examine other ways this metric can be utilized. Dottie's Dolls and Accessories creates dolls, doll clothing, and doll accessories. Most of the time, their output is fairly uniform except for a Christmas surge, which usually starts in November and falls off after Christmas and through late winter. Production then resumes normal operations in the spring. By keeping track of their historical capacity utilization, which usually sits in the Goldilocks zone, Dottie's is able to adjust production to account for predicted levels. In peak season, they'll increase capacity to meet demand, often to 90%. They do this by working longer shifts, using overtime labor. This will raise the cost per unit, but it's temporary, and they'll make it up in volume. However, this year, Dottie's introduced a new line before Christmas, and orders were far greater than expected. Fulfilling them put them dangerously close to full capacity, with no room for error. They were then met with two options: increase capacity by adding on to their production floor, a costly option which may not be feasible in the time allotted, or subcontract some of the work to a trusted partner. Dottie's took option number 2, and it paid off. They were able to fill all the orders in time for Christmas and had some breathing room to plan for the following year. The importance of tracking capacity utilization. Capacity utilization tracking matters because it informs decisions at every level of your operation. 4 areas benefit most: strategic planning, operational management, financial planning, and early warning detection. Here's how each one works. Strategic planning benefits. Capacity tracking helps facilitate your biggest strategic decisions. Consistently high utilization, 85 to 90% plus, signals time to expand. Persistently low rates point to efficiency problems worth solving before buying new equipment. The data supports long-term planning by showing capacity trends over quarters and years. It also answers the make or buy question: do you have capacity for new work, or should you outsource? Operational decision-making. Operational decisions happen daily, and you need streamlined, accurate data to make them. Capacity data answers the critical questions. Can I take on new orders? Your current utilization rate tells you. How to set production schedules? Base them on real capacity, not wishful thinking. Is production slowing down? Capacity tracking often identifies the bottleneck, whether it's a specific machine, process, or resource constraint. Without current and accurate capacity data, these decisions become mere guesswork. Financial implications. Financial planning also needs solid data. Capacity utilization provides it. The metric shows your break-even point, exactly when you cover fixed costs. It also informs pricing decisions, as higher utilization means lower per unit costs, giving you pricing flexibility. If you're considering expansion, calculate ROI using real utilization trends, not guesses. The data also shows whether to focus on reducing fixed costs or controlling variables. Early warning system. Keeping tabs on your production capacity allows people to stay proactive with both good indicators and warning signs. For example, consistently high capacity utilization indicates the need for expansion. You've hit and maybe gone beyond the 85% sweet spot, and it may be time to add new machinery, more automation, personnel, or manufacturing space. Persistently low utilization indicates inefficiency or market forecasting issues. If your numbers are down, you may need to look for bottlenecks in your process. This might also be an indicator that a root cause analysis study needs to be performed. Additionally, you may need to do a thorough study of current and future market demands. It also helps prevent capacity crises before they occur. If you know that demand might increase through your forecasting efforts, you'll know where and when to beef up your operations capacity. Finally, it enables proactive rather than reactive management. Instead of rushing in to put out a manufacturing fire, only to have another one pop up elsewhere, you can see where potential problems might occur. This allows you to address the issue before it becomes a full-blown crisis. 5 strategies to optimize capacity utilization. 1. Implement lean manufacturing principles. Lean manufacturing tools help eliminate manufacturing waste, any work process that fails to add value. Walk your line and look for operators hunting tools, materials placed at the wrong workstation, machines waiting. That's wasted capacity hiding in plain sight. Things like time wasted hunting for tools multiply across your workforce. It's hours of potential capacity without needing any new equipment. Or maybe you have 25-minute changeovers in a day, which equals 100 wasted minutes. Apply the 5S system: sort, set in order, shine, standardize, sustain, or use SMED, single minute exchange of dies, to identify and handle these types of inefficiencies. Small improvements compound to grant a considerable percentage gain. Hunt for them systematically. 2. Optimize production planning and scheduling. This is where things get interesting. You might have one machine running at 95% while an identical machine sits at 60%. That's not a capacity problem. That's a production scheduling issue. Better scheduling means looking at your whole operation, sequence similar jobs together to minimize changeover time. Switching from red paint to blue paint and back to red again? You're wasting capacity on unnecessary cleaning and setup. Plan smarter. And here's the thing about equipment specs. They show theoretical capacity. Your stamping press might be rated for 100 parts per hour, but if it's actually producing 85 in real-world conditions, plan for 85. Otherwise, you're setting yourself up for missed deadlines. Production scheduling software helps model different scenarios before committing to a run, shows you the bottlenecks before they happen. Worth considering. 3. Demand management approaches. Customer demand creates peaks and valleys. Managing those smooths out capacity utilization. Some companies offer modest discounts for orders during their slow season. Customers get better prices, and you keep capacity utilized. Both sides win. If you make products with seasonal demand, remember the toy manufacturer example. Developing complementary product lines that peak at different times helps. Not always possible, but effective when it works. Communication matters here. Clear conversations with your sales team and customers about lead times are essential. Many customers accept slightly longer lead times if you're honest about capacity. That beats promising delivery you can't meet. 4. Workforce optimization. Your people matter as much as your machines, maybe more. Cross-training prevents bottlenecks. When the one operator who knows a particular machine calls in sick, what happens? Cross-train your team to cover multiple operations. Flexibility keeps the capacity flowing. The 85% sweet spot applies to your workforce too. You can't run people at 100% indefinitely. Overtime starts, productivity drops, quality suffers. Eventually, someone gets hurt or burns out completely. Train your people because skilled operators produce more with fewer defects. Making your people better at what they do is direct capacity improvement. Lastly, number 5, technology and systems implementation. Spreadsheets and clipboards can't manage modern manufacturing. Manual tracking simply lacks the real-time visibility required to keep everything under wraps. To prevent expensive mistakes like overcommitting capacity, missing deadlines, or having to run emergency overtime on poorly planned work, consider manufacturing software. MRP systems show you what's happening now. They automate big parts of capacity planning, alert you of approaching limits, track material availability, and help sales quote realistic lead times based on current capacity. Small manufacturers don't need enterprise complexity. Cloud-based systems built for your size deliver visibility and planning without overwhelming features. Successful manufacturers aren't those with the most capacity, but those that manage existing capacity most effectively. Real-time utilization visibility, accurate planning data, and smart decisions about new work versus expansion. That wraps up this episode of the MRP Easy Manufacturing Podcast. Thanks for tuning in. For more information, go to mrpeasy.com. See you next time.